Hey, have you ever found yourself just staring at a loading bar, waiting for some big computation to finish? Well, if that sounds familiar, this explainer is for you. Today, we are going to dive into Nelson's parallel module, and I'll show you how to unlock parallel functions to seriously speed up your code.
We have all been there, right? You hit run, and your entire program just stops. It freezes up, totally blocked by one single flow task. It's a super common bottleneck, but thankfully, it's one we can totally fix.
And this slide just perfectly shows the difference. On the left, you've got sequential code. It's like a single file line at the grocery store. One person has to finish before the next one can even start. But look at the right. Parallel code is like opening up a bunch of new checkout lanes. You can process several tasks at the exact same time. It's a game changer.
So here's our roadmap for today. We'll kick things off with why you should care. Then I'll introduce you to the parallel module. We'll walk through your very first background task, learn how to juggle multiple jobs, and finally, cover how to stop and manage them. Let's get into it.
So really, why go parallel? Well, it's because running those heavy tasks one after another just blocks your entire program. It becomes totally unresponsive. By offloading that work to the background, you free up your main session so you can stay interactive and, actually get stuff done.
And the solution to this whole waiting problem is Nelson's parallel module. The best way to think of it is like hiring a dedicated team of background workers. They're ready to handle all your toughest computations without ever interrupting your main workflow.
The official definition here really says it all. It gives you tools to run functions asynchronously, which is just a fancy way of saying at the same time as your other code. And you can see the key players right there in the text, the background workers who do all the heavy lifting for you.
Okay, now for the fun part. Let's actually put this into practice. Running a parallel task in Nelson follows this really simple, repeatable recipe that we're about to walk through right now.
It all comes down to these three fundamental steps you see here. That's it. First, you create a pool of workers. Second, you run your function on them. And third, you fetch the result when they're done. Create, run, fetch. It's that simple.
So step one is creating that environment with background pool. This one command sets up your entire workspace and gets your team of background workers ready and waiting for instructions. This is the foundation for everything else we're going to do. Step two is where the real action happens. You use parvel, which just stands for Parallel Function Evaluation, to send a specific job to one of those workers in your pool. Now, this command is cool because it immediately gives you back what's called a future object. Think of it like a receipt or a claim ticket for your job. And this slide breaks down that parval command perfectly. You just tell it which pool to use, what function to run, how many results you're expecting back, and then finally, any inputs your function needs to do its job. See? Super straightforward. And finally, step three, the payoff. Once your background task is all done, fetch outputs is the command that goes and gets the result. Your main program will actually pause right at this line, wait until the answer is ready, and then pull it back from that background worker. Okay, running one task is great, but the real power comes from managing a whole bunch of them at once. Now, you get to become the head chef, coordinating your entire team of workers. So this slide shows you two really important tools for coordination. You can use after each when you want to process results as they come in one by one, and you'll use after all when you need everything to be totally finished before you take some final action, like say calculating a grand total.
But hey, what if you don't want to wait for everything? What if you want results the second they're ready? Well, that's where Fetch Next comes in. It literally grabs the result from the very next worker that finishes its job, which lets you build way more dynamic and responsive apps.
And the proof is right there in that finished IDX. When you use Fetch Next, this index tells you which tasks just completed. And as you can see from the numbers on the screen, they don't finish in order. The 8th task might finish before the first one. That's parallel execution in action, folks. It's awesome.
All right, with all this power comes the need for a little control. Sometimes you're going to start a task that you realize you don't need anymore. It's so important to know how to properly stop and manage these jobs to keep things nice and tidy.
So what do? I mean, you definitely don't want a worker wasting precious resources on a calculation you've already moved on from, right? This is where the cancellation functions become your absolute best friend.
Nelson gives you two pretty clear options here. You can use cancel with a specific future object to stop one single job. Or you can bring out the big guns and use cancel all on the pool's queue to just wipe out everything that's currently running or waiting in line.
Okay, now here is a super important warning, and this comes directly from the documentation.
You need to be aware that some operations, especially things like file I/O, like the save function, they are uninterruptible, so even cancel won't stop them. That is a very practical real-world tip to keep in your back pocket.
So, if you remember just one thing from this whole explainer, please make it this slide. The core workflow is just so simple: create a pool with background pool, send a job with parfev, and get the result with fetch outputs. Master these 3 steps, and you have honestly mastered the basics of parallel computing in Nelson.
And that brings us to the end. So I'm going to leave you with this question. Take a look at your own projects. What is that one slow, blocking process that is just begging to be offloaded to a background worker? Go on, give it a try. Thanks so much for watching.